Okay. Welcome everyone. We'll give another maybe 30 seconds for everybody to join, and then we'll get started. I'm really excited to have Fino today. Really going to uh, dive deep into PLM. So give about just 30 seconds here, Fino, while people
Yeah.
dial in or get themselves situated. Grab a beverage or whatever they're going to do and sit with us for an hour.
Probably too early for a beer on your side of the ocean. Probably about almost beer o'clock over here.
Yes. Yeah. I guess it's about 5 o'clock for you.
Yeah, I'm
You're
sitting
over
in
there in Central
Paris while
Europe.
you guys.
Yeah.
I'm
Beer
sitting
o'clock.
in
Yeah.
Paris,
Not.
France.
Well, I guess depends on where you are and what you do. But yeah, here in the East Coast, it's 11
A little
a.m.
early.
So do appreciate you coming on here at the end of your day.
Oh, and it's not a problem. I'm looking forward to the conversation. It's gonna be fun.
Good. Well,
Hey,
so yeah,
oh
thanks, Chris.
crap! You guys spelled it wrong. It's I-A-R-I-A-R-O, not A-R-I-O.
IARO.
Yep, I-A-R-O. It's actually
Okay.
wrong. Also in the little thing on my where
Well,
my name is.
okay. Well,
Forget
thank you
that.
for pointing that out. I'll have to.
I
Sorry
don't
we
think I
did that.
typed that in. I think that you
So
guys typed that. Yeah,
okay.
Finocchiaro.
Oh yeah. Okay. Good. Okay. So today we're gonna, Fina, we're gonna talk about. I think what everybody's talking about is AI, but not specifically around PLM. Right? You've been working in PLM, and so I'm excited to. So welcome to the CAD Talk Integrate Intelligently podcast. Great to be talking. I follow you on LinkedIn, so this is a bit of a privilege for me. So thank you for joining.
Oh, you're welcome. It's my pleasure. I was really happy to that you guys contacted me what 3 months ago, and we organized this interview. So I'm looking forward to learning more about Cat Talk and talking a little bit about what's happening out there and with AI and the PLM vendors and the startup community. So this will be fun.
That's Yeah, that's really cool. Obviously, I mean, AI is all the rage. So just the way I came across you, Fino, just kind of plug CAD Talk here is like why we're having this is, CAD Talk works in what I call the messy middle between PLM, CAD, PDM, and ERP. Right? We handle that. Uh, I would call that messy middle where you need to communicate back and forth, and we do. We have integrations with our that translate between the two systems. And so that's where I came to find you on LinkedIn. And so I reached out. And so really glad that you're here. Looking forward to learning more about your experience at AI and, kind of what you're doing. So, obviously my experience with CAD and PDM and PLM is really through CAD Talk. So I'm kind of as a messy middle, right? I connect to these things. I'm in the ecosystems, but you clearly have a deep dive, right? You're the guy who's spent a career, a lifetime at all the big players. So tell us a little bit about your journey, what you did, how you got into that. Obviously, you're the expert here. I'm a dabbler, right? I help customers with get their with their data and get those things talking, but you're the pro here when it comes to the engineering side in PLM.
I'll try to do it real quickly. I started actually on the CAD side because back in the early to mid 90s, we still had these things called Unix workstations, which were sort of like the same size as a washer dryer, and that could do graphics about like less good than on my phone. And then those all disappeared in 1997, roughly, when the NVIDIA GeForce came out. And I was basically tuning the graphics drivers for those. I always loved the performance side, and then I switched over to PLM, and so became the guy who knew how to tune that. And I was back. I started then with the hardware vendors, IBM and HP, which were two of the big Unix workstation providers, alongside Sun Digital and Silicon Graphics. Um, and then I did PLM, and I became a windshield guy for quite a while, the windshield guy at HP. And then HP decided that they hated everything with three-letter trigrams. And so I left and went to PTC, since they already knew who I was. So I was already tuning their systems. And that was when PDC performance was really, really nothing to brag about. In fact, it was pretty bad. And I was the guy in the airplane 2 or 3 countries a week trying to tune these systems and telling PDC to fix it. And they were like, and I said, but it's software, it's fixable. Yeah, I got recruited over to IBM again because DS was doing this V6 thing, and IBM wasn't getting information. And I joined IBM just in time to be sold by IBM to Dassault back in 2010 in the Teranga deal. 700 of us sold for 600 million. And I spent about 7 years at Dassault in various roles. I started in R&D, worked for a while in the Innovia brand, always dealing with the platform, being the expert architect and the performance guy. At one point, they split, well, it's sort of my idea, but they split the Innovia, the PLM application from Innovia, the platform, because they used to kind of amalgamate everything into one big blob. When they split that, I couldn't stay in Innovia, the PLM app anymore, because I was the architecture platform guy. And so for a while, I spent a little bit of time in pre-sales and couldn't really find my place, and ended up leaving in 2017. After having lived through the whole and actually guided part of the journey of Dassault down the 3D experience route, which was interesting. And I've been independent since around 2017 with a very short stint at a PDC reseller where I learned about ThingWorx and the IoT MES kind of world. So I've got kind of my feet in both the engineering side and the manufacturing side. And for the last year or so, I've been looking at doing various missions here and there, but also studying very closely the startup ecosystem, like you wrote down here, like a lot of posting on LinkedIn. I've got a newsletter. I've got 2 podcasts. The Future of PLM with various thought leaders in the PLM area, and AI across the product lifecycle. I talk to startups, and I've researched now. I just put in my database the 440th startup. So actually, this slide is
you just keep adding them.
12.6 billion in VC.
Oh wow.
Around 50 billion probably in market cap, something like that. There's at least 6 unicorns. So yeah, it's much bigger, I think, than anybody really realized. It's certainly bigger than I realized when I started out, and it's really exciting. And I feel very privileged to have talked to many of the founders, about 70 founders so far, about what they're doing, and it's really, really incredible. This rate of change is just is astounding. So that's sort of where I'm at.
Yeah, I agree. The rate of change is astounding, and it's cool to see. I got 2 points. It's cool to see this area get attention, right? Because I talk to a lot of customers, and you're not like, well, at least where we are, we're the less exciting part, right? We're in the middle, but it's still good to see like people still interested in PLM and CAD, and like CAD I get because of what you can do with it, but PLM, it's good to see people interested in starting companies and improving those processes, improving those softwares, because with AI, all the attention gets sucked up by the consumer stuff, right? So my second point was interesting to hear your backstory. What was were you like a software developer, an engineer? Like how did you, from a school standpoint, how did you get, what is it?
Yeah, I'm a mechanical engineer. I went to University of Florida and did my BSME, and actually never actually got my MSME because I really hated my my professor, and he ended up being fired for various reasons, despite having tenure. Anyway, all that to say, yes, I have a mechanical engineering background, but I very quickly I saw the light pits and everything, and I started looking at computer graphics. In fact, the reason I got my first job at IBM was that I was in the CFD guy had received an IBM 520, this big like refrigerator or college dorm room refrigerator sized computer, and he couldn't get it to work. He couldn't get the graphics to work, and so he said, "Oh my God, I spent all this money." And he actually called John Akers, which is like insane. He called the head of IBM at the time, and the guy head of IBM basically told his team, "I don't want to ever hear this guy's name again. You just get a student up here for 7 months. He figures it out, and he goes back, and I never hear from the University of Florida again, which is what happened. I was the student that went up there. The amazing coda to that story is that same group I worked in. The year before, there was another guy that had that graphics job, because it was basically the team that was porting all the different CAD packages and 3D packages to the IBM graphics. And they was basically the old IBM graphics cards that were attached to a mainframe that were attached into these Unix workstations. The guy that was in that group with my job the year before became the youngest billionaire in history, and
Wow.
that was Mark Andreessen of A16Z.
Oh yeah.
He was in the same group as me, but a year before.
Wow.
I never met him, but apparently he was thin once. That was a legendary
Incredible.
story I got out of it. Yeah.
Incredible. Yeah. Yeah. It's you never know where you're going to end up.
No.
That's the I never know where we're going to end up. So let's kind of oh. So I want to make sure we define our terms here for anybody. I'm sure most people in your audience will know. This might be for some of my audience, but for your audience as well. PLM is really around product lifecycle management. Really, the idea of helping engineers that kind of manage the product, right? Because CAD does some of that, but PDM does some of that, but PLM really takes that to a new level. And then agentic AI, of course, we hear AI all these days, all these terms, but agentic AI is really around doing things in the background independently, tasks that we can do, so that more than just ChatGPT, but really taking actions behind the scenes automatically, and so orchestrating workflows, getting things done. So we're going to talk about those things so people really know kind of where we're starting, what this conversation is about. So you've been doing this longer than me. I've worked at CADTALK. This is my 11th year, and I've been working in these sort of systems. But you've been doing it a lot, 30 years. What has been, I guess, what has been the good things in the last 30 years, right? Like what were you like, man, this was really great, these things? I mean, everything's a journey and a process, but talk to me about what worked really well.
Well, it's interesting. It's an interesting question. What worked well really was how we've been able to take technology and adapt it to changing the way that we do engineering, right? Because it used to be pencil and paper, and we started using computers. But with computers, your user interfaces were a bit kludgy, to be to be kind to them. And over time, we've been able to make the user experience a lot more smooth. And I think we're seeing that even more now in the more agentic or the more AI native applications. I think that the fact that we're able to make it easier to use also democratizes access to
Right.
a lot of the things, because I think that even as a non-programmer, you can use vibe coding and create things that actually work. So
Yeah.
same thing as an engineer, you can scaffold some ideas and then use AI to kind of build them into something.
Yeah.
And then you can actually create a whole application. I've talked to now 20, 25 startups roughly, interviewed them on my podcast, talking about how they use AI on a daily basis to create and modify their applications. So I think that that's one of the things that really works well. Also, one thing that's getting better is data governance, because up to now, a lot of the companies have kind of siloed their data into various organizations. The engineering guys had their data and didn't really share it very much with the simulation guys, unless they had to. And then manufacturing was sort of a throw it over the wall and hope someone's going to
Yeah.
catch it. And what works well now is that we're starting to see better digital threads, more robust and even cognitive digital threads, so that transmission of data, that connection between the different departments is a lot easier. I'd like to add too, in terms of agentic AI, I really like the way that Aora Berry, who runs the AI strategy for PTC, he created this idea of a framework that he called Advise, Assist, and Automate, which I think really describes the mission that we have, which is in the beginning of the. Go ahead. Sorry.
I was going to say, from just hearing about it, it sounds like, the first step is to advise, right? Give people the information they need.
Yeah, it's
Second
sort of
step is,
read only.
yeah,
The second step is, here are some options. Which one do you want me to do? And the third
right.
one is you give them actually a workflow, like two, three, whatever, in steps with the guardrails on it in order to actually execute a task. So I like that framework. Basically, I think it really works really well.
Yeah. And you being an engineer yourself and probably work with a lot of engineers, I think they would, and manufacturers, my experience, much more likely to adopt if they feel in control rather than go straight to like, it's going to do it all for me. People go, whoa, 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 wait a minute, you're going to do what for me? What are you going to do for me? So I think walking down in the path of each step, letting people see each step and see the value and the benefits, and then get comfortable, right? And then, of course, I think all of those will have a role, right? There will be a role of advise, assist, and automate throughout.
Yeah, I just thought the idea of using the three A words was a good framework and a good way of describing even the evolution of AI technology as we're starting to adopt it into engineering and manufacturing workflows. I wrote a whole series about that last year. In fact, what I find also in terms of that, what's working over the last 30 years question on the previous slide was that up to now, we've been sort of also only working in our one discipline. The mechanical engineer was working on mechanical engineering, and the manufacturing engineer would then take over. And what we're seeing is a blend of those things now. Now I have tools that are powerful enough to give me an idea to do design for manufacturability or design for
Hmm.
sustainability. And those are becoming real things. So I'm becoming
Hmm.
more multidisciplinary. And I find that really interesting. And then last year at his various talks, Jensen Huang talked about how physical products and physical factories will have in the future, which is really now, AI factories associated with them. Every physical factory will have an AI factory. And I think what we're doing as an industry in general is creating those AI factories, or creating the building blocks for those AI factories of the future, which I find really fascinating and exciting.
Yeah, you were mentioning that. Uh, to double click back on like what you're talking about, like breaking down silos we saw the last 30 years, where you have engineering and people. We've played our own role in that, right? As the glue or the between is like that design for manufacturing. We have a product called that can help break down those walls, right? So engineering needs to talk to manufacturing, right? So that you can design in such a way that you can actually manufacture that. And yeah, I agree that that's something that I expect to be even more so, even with the AI, right? The agentic AI, even more so that those those departments will not be so walled up, right? There'll be a lot of communication back and forth, and it'll happen naturally, right? With the AI, and you'll be able to get what you need where you need it, when you need it, much more easily.
Exactly.
So talk to me a little bit about like, so our conversation really around now is kind of like what there was, right? What it used to be, and then which I want to talk about now, and then like kind of where it's going, and why and what the benefits are of that. So you meant
Sure.
you dropped a bunch of big names, right? PTC and
Yeah.
Siemens
So
and Dassault, of course. Those are the biggies, the big three. There, I imagine. I'm not as familiar with the history of PLM, but I imagine they were all involved, maybe PTC, with the development of PLM, right? And
yeah.
they've had the kind of the we I know from a market standpoint, from a customer standpoint, right? Those are the big three we talk about all the time. What we have access to, some PTC products, some Dassault product, and some Siemens product.
So if we go back a little bit further before that, the development CAD that came around, actually the first CAD system was built for manufacturing. It was Dick Sowers. They ended up buying ASUS from a company called it was Three Space, and then that became ASUS, the first modeler. Those guys then also split off and created another company called Shape Data, which became Parasolid, and Parasolid became, of course, the core of Unigraph, what is now NX, but also SolidWorks and Onshape.
That kernel, right?
So
That
basically,
original kernel.
that original kernel. So basically, that you had a lot of you had maybe 15, 20 companies doing CAD that sort of consolidated around 4 or 5.
Right.
Because AutoCAD is also a significant one, even if the 3D side is relatively small compared to the other three. And you also had this a tiered effect, right? You had for a long time you only had the high end stuff, which was CATIA, Unigraphics,
Right.
and Pro E, and then you had, starting with Windows, the Windows stuff in 2000. Then you had SolidWorks, Solid Edge, and stuff like that. So those companies, the biggest ones, realized that they had all this CAD data, they didn't know how to manage it. So first thing that came out was PDM, product data management. How do I manage the data files? And in that we had things like actually it was Pro PDM, and then it was Pro Interlink. There was iMan for the Unigraphics side, and in the Dassault universe there was VPM, which was the data management tool. And in the course of developing those and the early to late 90s, people started saying, well, actually, if I'm already going to manage the files, why don't I manage also the life cycle on top of those files? So we started talking about this idea of, it's not just the design, I also need to pass that to manufacturing. So there's a life cycle just between engineering and manufacturing. And so and then you saw this massive wave of consolidation, which became somewhere, let's call it 2005, 2007, you had PTC with a rebranded Pro E called Creo. You had Unigraphics, which got bought by coming out UGS, and then they were bought by Siemens, and now you have Siemens Digital Industry Software, DISW. And CATIA has always been CATIA, but CATIA, of course, Dassault had acquired SolidWorks. They have both the high end and the middle layer. I guess actually all three of them do. Siemens has NX and Solid Edge. PTC has Creo and Onshape, and Dassault has CATIA and SolidWorks. And so basically the PLM was a wrap around that. It was also a way, obviously, to sell more software.
Sure.
They're
all in the software business.
And then I'd say around 2000, you had several companies. In particular, you had Eris and you had Bomb.com, which was later Arena, and then that was purchased by PTC, who decided, well, no, I don't really need a CAD. I can just do PDM or PLM even. And so you had a couple of companies, and I think Bomb.com probably can claim to be the very first cloud-based PLM system. But you also had Eris, which was doing both cloud and on-prem. You had a handful of others. You had Matrix One, which was then bought by Dassault, and that became Innovia V6. So yeah, it's a little complicated, but it really just goes from CAD to PDM to PLM. And then these PLM vendors became huge, and so started growing the scope of PLM even beyond engineering and design to cover service lifecycle and model-based system engineering and ideation. And so they became these really bloated, humongous mega corporations now.
Yeah, even manufacturing, right? Some of them have
manufacturing, Delmia, and exactly. Well, both basically Siemens and Dassault went all in on virtual factories, but also the CAM and the tooling and the routing and machining and so forth. PTC was more on let's do the asset lifecycle management. So they bought ThingWorx for that. And then very famously last year, they decided to sell that off to somebody else. So they're refocused back on PLM and CAD once again with the requirements management and Codebeamer, which is a little different than the other two. But yeah, so there was this great consolidation around PLM and CAD. There was also consolidation in the last 3 to 5 years, probably, in simulation, right? Because Dassault had purchased Abacus and created the Simulia brand, but then Siemens has been acquiring like crazy, CD Adapco, and most recently Altair creating their simulation thing. So I think, and then you had last year the sale of the Hexagon's MSC to Cadence, right? And Synopsys bought Ansys. So you've had a lot of consolidation around simulation as well, which also somehow gets tied into the whole story of PLM. And then if you want to get even more crazy, you've got Siemens buying Mentor Graphics, so becoming an ECAD vendor and a CAD vendor.
Yeah.
So they've all become these like big monsters.
Yeah, I mean, you see it like kind of leads us into the next thing is like they buy all these, they buy them all so they can combine them, right? And have they'd be everything, right? I'm the one vendor. Because from a software standpoint, if a software company, you want to sell software, you want to be the one vendor that sells your customer everything, right? Everything they need. No mix match, no use different vendors. We're the one platform that does it all.
Yeah, there's been a bit of a monolithic aspect to all of that, indeed, definitely, and um, and that's why I find it both refreshing and surprising that that I've found over 440 startups in this area already. I mean, I think the spike is around 2022 when probably more or less the same time that OpenAI releases ChatGPT 3 and then LLMs take over the world. But there was a huge jump right there. There were a lot of startups before, but there was particularly around 2022 a big jump where people started saying, well, actually, I'm not going to wait, 3 years for Dassault to develop this functionality, and I'm not going to wait, all this time for Siemens to come out with a Copilot. I'm going to buy somebody else's. And you're seeing a lot of these startups, you're going to be like, oh, well, who are their customers? Well, actually, their customers are Boeing and Anduril and all these drone companies, because they want to move much faster than the big three can move, because the big three are these big, they're huge, and they have they're not as agile as the smaller ones, and so you're seeing a lot of adoption of these quote unquote risky startups, but they're actually really stable. Like I said, I've had I think I've got at least 6 unicorns in there. You have companies like Schollab, which raised 72 million last year. Neuroconcept raised 100 million last year. Leo AI, which is only 2 years old, raised 9.7 million in September as an engineering co-pilot. So there's like some serious money being put in there, and to real products are being used every day by engineers building real products in the real world, basically.
Yeah, it's I did not realize that there were that number of startups. You know, so it's surprising to hear you say. I mean, because we still we we partner with all the big three, right? We partner with them because we have their customers need integrations, and that's where we sit, right? To help connect the
Of
systems
course.
together and get those working. But I'm surprised to see that I lost my slides there. I'm surprised to see. There we go. Go back. I guess we'll get to that. I'm surprised to see so many startups, not because it has been difficult, I guess, for companies to break in, because manufacturing engineering companies, in my experience, are pretty risk adverse, right? Very, very like, hey, stick to the thing that, no one gets fired for buying the thing that everybody
IBM.
knows, right? Yeah, for IBM. Sometimes in the ERP space, we'll joke that no one gets fired for buying
SAP.
SAP, right? No one gets fired for that. So I'm just surprised in an industry where risk aversion and what's I heard at one of these events, they call them what's it called, like instead of FOMO, it was FOMU, the fear of messing up, right? Because I'm
Mm.
just surprised, because it's my only point is that I'm glad to see it, but I'm surprised. But you clearly are not.
Well, it's more. I'm surprised that there's so many, but I'm not surprised that they're successful. With if you go into creating software today in 2026 and you start with a good foundation where you really explain to whatever tool you're using exactly the what you're going to build, then it's not that difficult to build production ready software. Um, and the companies that I'm talking to are building stuff that where they were working in, most of them have worked in industry at SpaceX or Tesla or Formula One, and seen some of the more what's the word I'm looking for? Well, seen some of the dysfunction and the way the engineers work because the tools don't do what they want them to do, or the processes, the way people work because of the tools and because of uh, well, because of what's the word I'm looking for? Well, just because of the legacy, the technical debt to all these other systems and ways of working, it's just inefficient. Like I talked to Michael Rosam of Quix, Quix. He's ex Formula One, and he said, can you imagine that these guys that are building these Formula One cars that are worth 15, 20 million a car, with even more millions of R&D behind that, the test data is just piles of paper on desks. None of the test data is actually digital. And he's like, I couldn't believe it. So I built the test system to digitize all that stuff and to make it go faster. And so that's the base of his startup. Same, like I think Adam Keating would say the same thing about design reviews, and then why he built auto review, because design reviews are a big mess when you've got you're using CATIA, but the other guy's using Creo. Well, you're stuck. How do you, other than doing lots of conversion and then it's a pain in the neck and it doesn't work? How do you solve those problems? Because the vendors are not, the big three are not very happy to allow collaboration with one of the other guy's CAD tools. So they're going to do everything they can to make it painful so that their supply chain and all their users are on the tool of choice, right? So I think that there's a lot of frustration there. The other issue, and I'm not going to name any names, but I know that some of the vendors have arbitrarily started raising prices without delivering any new value. That's also taking, even very conservative companies are saying, well, no, I'm not going to, there's alternatives. And some of them are calling me and saying, Fino, what can we do? Because we're not going to, we need alternatives. We know these other companies out there can do some of the heavy lifting, maybe not all of it, but at least we'll be able to move a little faster, and maybe it'll be more price efficient, because paying for software that's heavily customized and paying an enormous amount of time and effort and trying to keep it up to date despite the customization is already a problem. And then to have them raise the price arbitrarily, and you're like, but what am I getting for that 20%? Nothing. It's just not the right answer, right? So I think that's some of it. I think also what's cool and what you're having on your side here is the agentic AI stuff. I think that indeed, when you put in the guardrails and you're very intelligent about how you deploy agents, like if you take Synera, for example, they're doing this with simulation data and combining CAD and CAE, and doing it with very intelligent workflows so that the engineers are able to follow where the data is going, but automate parts of their workflow so they don't have to spend their day copying the file from one disk to another disk, which was just a pretty disappointing amount of time spent by engineers just doing routine tasks. And that's the promise of AI and engineering, really, right? Is let's remove all the mundane so we can get to the more exciting, fun, innovative stuff. Yeah, and I guess the other point to your side, you're talking about architecture shift. There was obviously this shift about 2010, 2012 to the cloud, right? Every single vendor went to the cloud. That, of course, created the fact that it was much easier to collaborate. It's much easier to connect systems because you don't have to go through firewalls and so forth. Maybe we're going to see a bit of retreat from that model because of tariffs, because of all these kinds of other politically motivated things, and data sovereignty in general. And that's where AI is also helping too, because with MCP, the AI can figure out all those protocols and stuff. You just give it all the keys it needs, and it can figure it out. So ultimately, yeah, the architecture shift is going to be more towards agentic workflows using MCP or other agent-to-agent protocols, and kind of figuring out how to do interfaces. I don't know if you talked to Michael Core of Duro. He just did his exit. So Michael, he just exited. He sold. Altium acquired Duro about 3-4 weeks ago. Michael actually rewrote all of Duro. It took him like 4 years to write the first Duro. And then after the ChatGPT revolution, he told his team, well, no, we're going to start over. We're going to write it AI native. But what I want to do is, well, what he ended up doing was basically having AI write all the interfaces to all the other software. He said, there's no point in having a developer sitting there figuring out what's the input and what's the output and how do I, that's AI is really good at that. And so the development process, instead of 4 years, it took him like 6 months to rewrite all of Duro, AI centric or whatever. And I guess that was convincing enough for Altium to hand him a sum of nobody even knows how much to buy his company and integrate it into their thing. It's still,
Yeah, no. Yeah. So one of the things I wanted to ask is like, what have you seen from the agentic workflows? I mean, there with any new technology, right? The technologists, I hear it too, and you get excited, and they promise lots of things, and then there's been somewhat not a bubble burst in terms of like the economics, but more of a letdown, right? Like people spend money and do a bunch of stuff, and like, oh, let's we're gonna boards and investors wanted you to do AI and get AI going. And I guess where have you seen it? How is this different? Not that it's not working. I mean, yeah, yes, I know Duro did that, but like, talk a little bit about like you're talking to these startups. Like, what are some use cases for the agentic AI that people are using today? I'm just not familiar.
Uh, Well, if we just start with AI in general, one is AI makes it incredibly simple to write product requirement documents. So a lot of the
Mm,
documentation you need to build software, you just describe to AI what you want to do, and it's going to create all the documentation and then walk you through it step by step to make sure nothing's missing. So that's really useful. Almost every single startup I talk to is obviously using AI in the development process as well.
mhm.
Their developers are either using Claude Code or Cursor
Sure.
to develop the entire application. Um, After that, there's a decision point. Do I do my own? Do I train my own models or do I use the public models?
Hmm.
So most of them end up using the public models mostly, and then using RAG or other techniques to augment them. But what really works is when you start adding domain knowledge and being able to really train the AI on understanding what is mechanical engineering, how does manufacturing work, how do I
Right.
blend knowledge from different disciplines so that overall my efficiency gets better and I become a better engineer. And that's where I think we're seeing the biggest breakthroughs. And that is also applicable to the manufacturing space because I'm seeing a lot of startups as well. It's like In Use is a French startup, and Laurent Couillard's idea was, well, let's allow these machines to talk to each other. It doesn't seem need a human. If there's two machines that need to coordinate something, we might as well facilitate that. I think that Flexbotics does a little bit of that too. Um, and then you've got well, anyway, there's a billion use cases out there, but it's pretty exciting to see how people are leveraging the power and possibilities while maintaining guardrails. Because again, the concern
Right.
people have, of course, is that the AI is going to hallucinate and things are going to go completely haywire. Um, I sat on a conference earlier in 2025 about AI, and there was a professor from Oxford University that had a pretty interesting observation. She said that, airplanes have these black box modules, right? And so if the airplane crashes, you can always roll back and figure out what was the cause. What we need is that in robots. So if when a robot kills somebody, and it will happen, some
Sure.
convenience robot's going to go nuts, and someone's going to get hurt or die, and there's absolutely no standard. There's no black box for robots yet. So she was already pushing the idea of we need a black box for robots. He was calling an e black box or something like that. And my thing is like, well, we need that for manufacturing and engineering. We need some standard for ensuring that when I'm using AI to make a decision, that's written down somewhere so I can roll back and figure out if something goes wrong. Was it was it me as an engineer? Was it the AI hallucinating? In which case I need to fix that. It becomes incredibly complicated, and that's where I think
Yeah.
there's a bit more progress needs to be made there. I and another thing I like to say is that the agents, the ones that we use every day, Claude Code and ChatGPT and Gemini, are trained, of course, on Reddit data, and they're trained to be super friendly and tell you how great you are and how
Yeah.
brilliant
Yeah.
you are. And
They're
I think
they're
that I think we need Maimonides agents. We need agents like, I'm not really sure. I doubt it. No, no, wait a second.
yeah.
Start
You
over
need
here.
an
I don't believe
engineer
you.
agent, right? You need
I
an
need a,
engineer agent who asks
or
you
I
questions,
got
everything.
Maimonides,
Yeah.
a
Yeah.
doubting agent. One is trained in
Yeah.
doubt.
Doubting agent. Yeah. Yeah. Yeah.
And
Yeah.
I'm not
We'll
really
train those.
sure.
Yeah. We'll train those on engineers, like engineering forums.
Yeah.
Yeah.
So
No, that's funny. How do you, I mean, we talked about talk a little bit about how does architectural changes in software from what we used to have, like, how do you think is going to help AI and these workflows?
Well, I think that I'm not I'm not sure exactly which changes. I think well, I can start and mention that uh, modern coding, when you're separating control and data and view, um, is going to allow us to have obviously user interfaces that are much more adapted to the human being without worrying about the implementation, right? And that's sort of what chat has done. It's basically just given us this text interface, and behind the scenes, we don't need to worry about, well, do I need to click over here and click over there? We're eliminating all of that. Um, and then when we talk about architecture, we need to mention, of course, graph databases, the fact that I can have these very powerful graphs that will make all the implicit connections between data so that I can see why a particular change on this part will have this downstream impact in manufacturing, and therefore I need to design it differently, or maybe come at it a different way, or maybe just change the order of the steps in my work instructions so I don't end up putting the worker in a dangerous position, or putting the part in a place that I can't really machine it anymore and it has to be removed and reset. That's really, I think that's all this thing around graph databases and cognitive digital threads that's going to allow us to, again, be more, engineers have become more multidisciplined. On my podcast, I like to also, because I've got the demographics of my podcast, I've got a lot of younger people also joining,
Mm-hmm.
and I like to always make the point of asking the founders what advice they can give to kids coming out of school, kids studying engineering, because a lot of them will, I think they're having anxiety. They think like, oh my God, I'm doing all this studying, and at the end of the day, it's going to be Grok or ChatGPT is going to have my job. And I think that the thing is that these kids, they still have to know the fundamentals. The problem is that they don't know the fundamentals, and they just trust what ChatGPT says. I had a customer talk to me earlier this week, I think. I said he had a simple problem. It's just one of these, you've got three unknowns and it's a fraction. You just have to multiply by,
Right.
across and divide. He didn't even do that. He just, the engineer, I'll put quotes around it, the kid that they hired as engineer, put it into ChatGPT. ChatGPT gave the wrong answer. And he said, but that's what it said. But did you check the math? I mean, it's off by an order of magnitude. Didn't you? No, I didn't check, because ChatGPT said, well, that's not engineering anymore. That's just whatever,
Mm-hmm.
yeah, in that case, you're totally replaceable by an AI. In fact, you're fireable because you didn't even get the right answer, neither did ChatGPT. So they should both be fired, and we should start over again. So that's sort of the danger. I think that we'll always need those fundamentals. We'll need to understand what is
Yeah.
engineering, and you, as an engineer, you develop a feeling for what the right answer is. You can look at something and say, no, that's not right. Even without having done the math, you intuitively you can see that sometimes.
Yeah, I think you hit on that. It's that fundamentals are going to always be fundamentals, right? Nothing's going to change there. These are just tools, right? These tools make the fundamentals better. I came from a different background originally in foreign language, and you living in Paris, probably had learned to speak French. When you're learning a foreign language, there are tools that help you, but that are just tools, right? The fundamentals still matter. You still got to learn the words. You still got to do the work. You can't rely on the tools 100%, right? You got to have the foundations there.
Exactly. Yeah, you got to be able to think for yourself a little bit.
A little bit, yeah. That's never going to go away. At least we hope so. We hope so. Okay, let's see what other topics we have here. Okay, so we know we talked about, like, I think one of the things about the architecture is like the open APIs. I think one thing we didn't talk about is like the OData and the REST and the open APIs, and we talked about how we know that AI is working, and so we're moving in that right direction, right? The market's moving that way with all the startups, as you mentioned. So I guess the next is like, now what, right? What do we do now? Imagine, like, as everybody, is all this stuff coming at us, right? We got, as you say, 400 startups or 12.6 million.
440.
What was it?
4.6 billion in VC, 50 billion
Yeah. So
in market cap.
yeah, I obviously can't try them all, right? But so it's like I guess where do we go from here? How do people who are listening and maybe watching, how do they engage with this, right? Like where do they start? What do they do? How do they, how do they think about it?
Uh, I, I feel tempted to use my tagline, which is Better Call Fino, right? But besides
Better
just
call
calling
Fino, yeah.
me, well, first of all, I think you need to assess really where you're at. You need to do a very honest and open-eyed assessment of your as is in order to determine uh, where the gaps are, where you have way too much dependency on customization, which makes code brittle and harder to update and upgrade over time. Um, you want to look at the architecture in terms of ensuring that you're not going to build yourself into a corner um, in terms of the scalability and the openness as well. So I think that an architecture that doesn't have really great cybersecurity is a waste of time. That's like absolutely primordial and needs to be primordial in your thinking. Uh, Also, I think you need to think organizationally in terms of separating the functions of data and IT. I think those should be separate lines of reporting because data really should be the oil that makes it function as opposed to just the gears, which are more the IT gears.
When you
And I
say
think that,
data, let me pause you there. When you say data, I assume you mean like data governance, right? The quality of the
yeah,
data, what data we want to
right.
collect, that sort of
I
thing,
don't,
which is typically an IT driven.
but it, which is unfortunate because I think it should be separate. I think there should be a chief data
Mm,
officer who's not the same guy that's the chief internal officer, the chief IT guy, or whatever you want to
right.
call him. I think there should be basically we're looking at a matricial world, right? You've got there's the business units, but I think you've got these horizontal elements that are supposed to bring those things together. And leaving it all in IT, those decisions aren't necessarily IT. A lot of the data quality is not. It's a data decision. It's not an IT. It's not an app that's going to fix it. It's the way of working. It's the way of thinking about it. So I think you need like a chief data officer that's going to define what databases, what formats, what we're going to use, and then implementing that would be people at the BUs would be the ones that the data owners, the data stewards would be the ones ensuring that their data is aligned with the corporate strategy so that when we need to do analytics across multiple division, multiple BUs, we can actually do that. So
Yeah, I
I think
mean,
that that's something that gets ignored a lot is that the whole question of data governance.
yeah, it's interesting because I hadn't really thought about it, but it makes a lot of sense because with the world of AI, that data, right? Your proprietary data, it is the fuel. It is the like it's the currency.
It's
It's
the
what
oil.
matters more than what I think I had a podcast with our founder. He talked about like the data was more important than the actual product you made because it's like with AI, that's really uh, the currency that you're going to be using, not the product itself. So to your point, the quality, because AI is using that data, the quality of that data, how it's structured, where it's stored, how we access it, what all of that becomes much more critical than just the IT infrastructure that it's on. I mean,
Agreed.
that's important too, of course, but
And I think
yeah,
it's a different skill too. There's our
mhm,
skills that are very IT related, and there's skills that are very data related. And I think
yeah,
they probably should be wearing different hats and not the same, necessarily the same. And so that's sort of to answer your second question on the architecture. In terms of what to look for in the startups, it sort of depends on your budget, right? If and how much risk you want to take.
right,
Because you do have startups that are a Series C, Series D, so they're already established. They're already in growth or expansion stage, and they're going to be a bit more expensive than maybe the seed or Series A ones.
right,
Um, but the seed and Series A, they're going to be a lot more inclined to listen to their customers and modify the product to suit the needs of the customers than someone who's already almost an established player.
right.
But I think it's really important to look at the backing they have, um, look at the pedigree of the founders to see how much experience they have. Um, and of course the customers that have already bought onto them, and you'll find that you might be surprised at some of the customers that are actually using a lot of the startup software. In terms of evaluating AI claims, well, basically you can check. Hopefully the customers are referenceable, and you can go check with the customer how the thing is actually working in the real world. Other than that, you can also just check if there's a bit of buzzword abuse, because someone who actually knows what they're doing isn't just going to be all buzzwords. There's going to be some real use cases and real
Yeah.
stuff. Although honestly, I mean, I've talked to almost 100 of them, and I've really not found very many that were not pretty spot on in what they were doing. I haven't talked to many that I would have just blown off as being PowerPoint jockeys as opposed to real engineers. That I've been impressed actually with what I found so far.
Not too much vaporware out there.
I don't think that people can really afford the vaporware. I think
Right.
if you're going to get if you want to be picked up by some of this money that's being thrown around at defense contractors, you've got to give them real software, because you'll be out within 3 minutes if you're not actually solving a problem. So I don't know if there's much room for that. I think there's room in other industries, but our industry, which is so critical and so fast moving, I'm not sure that there's a lot of room for that. I think that adoption is around giving the people interfaces that they can relate to. If you give them something with 1 billion clicks and just too messy, I don't understand it, that they're obviously going to be less inclined to use it than if you give them something that is much more natural and solves a problem. Because I think the other thing too is you've got to go to determine what the user pains are and really resolve a problem that the person actually has, in order for them to feel that, oh, I actually solved that problem. Well, actually, I do have this other problem I didn't tell anybody, and maybe it fixes that one too. And then it kind of snowballs from there. Of course, you're going to have a technical debt to one of the big three in most cases, and at least in brownfield accounts, right? And so those vendors will have maybe parts of the portfolio you haven't looked at. You can look at them and see whether they solve the problem and how much it's going to cost, and then evaluate a handful of startups to see if they also solve the problem at a lower price point or not. Most of the startups will already have some kind of integration via REST or OData, but hopefully over time there'll also be more and more MCP interfaces, so we can just get rid of all the magic and just connect the things. In terms of one thing this quarter, I'd probably look at the workflows and find the one place where things are really, where either you're getting a lot of complaints through the IT ticketing system, where people are complaining about the one system that doesn't work, and then go look at 3 or 4 startups and try to see if you can find someone to get past that. Because there's no reason, especially now, again, with the choice of 440 startups, there's got to be at least one that is something in the ballpark of what you need, I would think.
Yeah, so I kind of coming to the end here. I have kind of, I guess, how do you one more question? How do you see the? I imagine you don't think the big three are going anywhere, right? How do you think the?
Well, that said, Autodesk just announced a ton of layoffs, so who knows what's happening over in at Autodesk? But yeah.
Yeah. Well, there was also that speculation, I guess, that they were going to buy PTC. Wasn't there a speculation for a while?
They screwed up and released something which they shouldn't have. But yes, there was a failed attempt, which was really stupid. But yes, there was that.
So if we're pretty confident, or we think we're confident that the big three, aren't going anywhere, and then big three or big four, I guess those PTC, Siemens, Dassault. I guess we should talk about Autodesk. Those are all the big players. If those players aren't going to go anywhere, where do the startups, like, what are they there to augment? Are they to take away some aspects that the big three are doing, so as far as market share, or is there just whole new TAM, new market that they're addressing?
I think the answer is yes to both of those. I think there's a lot of white space in terms of newer technologies where the big three don't necessarily have a solution. The newer kinds of physics maybe to solve, especially in the simulation area, or um, uh, other than NX CAM, there's a lot of missing pieces in the CAM story where people need to connect to Gibbs or CAM or Master CAM or whatever. So I think there's white space, but there's also the problem of the mid-market, right? Because the big three are geared towards the Fortune 500. They really are not very good. Their PLM platforms are not that great for the mid-market. So that's also a place where OpenBOM and Duro and Propel and even Eris have had a lot of opportunity to grow because, well, Eris has been more Fortune 500, but I think that the mid market is an area where you're seeing more and more hardware startups as well, whether that's in energy or in defense, drones or whatever. Well, now that you guys have banned DJI, I think the drone industry is going to pretty much explode. There'll be a lot of development there, and so I think those fast-moving smaller startups are also going to be very avid of grabbing some startups to go much faster and not have that kind of vendor lock-in that they would have if they went only with one of the big three. Because of course, that's the issue. If you start with one of the big three, they're going to try to get you to eat the entire pie, even if you only wanted one slice.
Yeah. Well, we're about time, Fino. So thank you for this conversation. I really learned a lot. This is fantastic. So I want to plug your podcast, plug you on. I follow you on LinkedIn, so you can certainly, follow you on LinkedIn. I think either just had or you have a conversation coming up about bills and materials, bombversation. Maybe you already had that.
No, it's next week.
Oh, perfect. Yeah. You have that coming up. You have a podcast, and then of course your newsletter, PLM.
PLM Demystified. And by the way, I'm going to start a series of conferences that are called Threaded for startups. The first one will be in Warwick, UK on the 25th of March. The next one will be down in Miami on the 13th of April. And it'll be a forum for startups to come and meet other founders and talk about how AI is transforming engineering and manufacturing, and how to survive as a startup in the ecosystem. And I'll try to get it, well, particularly at the Miami event, there'll be a lot of bigger customers there as well, because it'll be a sort of tagged on to the Eris ACE event. And so the startups that come will be able to mix with the big customers that are there. So that's an ongoing thing. Those are the first two events, but I'm going to have at least 3 more during the year. So cool. You can also come join me there.
Well, that's great. I look forward to having more conversations. So really appreciate that. For joining us. We got it on the screen there, LinkedIn and newsletter and YouTube, and where to find you. And obviously, folks can find us at CADTALK.com, and of course, our LinkedIn CADTALK. And I'm Jeff Brickler. You can find us there. So, Fino, this was a great conversation. We'll let you. I think it's probably time for you called. What was that? Beer hour, beer o'clock, or wine o'clock, whichever one you do. So great talking to you. And thanks a lot. We'll talk soon.
Okay, take care. Thank you very much, everybody.